name is Milo Wilson, and this is a demo and explanation of my breadth first search 8-cube puzzle solver. So I'm going to have it run here for a minute it I explain. As you can see here, it is running through each of the states, and it's keeping track of how many states it's processing. So I'll start at the main method here. And the first thing that I do is get the initial time. Here you see that it was able to solve the, what's it called, the problem in 185,948 moves, and that took like 21 seconds. So I'm gonna run it again, and as I go through this, and so the first thing that I do is that the array I want to solve is that I call the method setUpArray. So the setUpArray method essentially creates a array and randomly places each of the values in different spots. So it goes from the first spot, second, third, fourth, fifth, sixth, so on. And then we only return the array if it is able to be solvable. The way I track this is basically when the board is generated, if there are a even amount of larger numbers before the smaller numbers, then it is a valid combination. Otherwise, it is absolutely not solvable, and my computer will just go into an infinite loop. Yeah, so we set up that array, and then we create a final array that we set to basically nothing. We start our counter at 0 here, and I have it print out the array. So if I, so I'm so sorry. If you can see the beginning of the array, it'll show you what the initial state was, and then it just iterates through. It first puts in the array that it generates and puts in the moves 7, 7, and 7, 7. These are impossible moves, and these are just placeholders so that the program knows that, hey, we haven't made any moves yet, so you can do whatever you'd like. And then current moves is the current move that we are doing, and next moves are the moves that we are processing. So as moves are processed, they move further and further into the front of the line, and we are constantly processing new moves, and every move that we process, we put more at the end. I'll go through that in a moment. So the first thing that I do here is that I print the current state and the final state. So as you can see here on this iteration, we print, hey, this is the array that it currently is on the left, and the final array is on the right, so that I can compare how close the solution is. And then at the bottom here, we display the not only the move that this board just took, but the move right before it. And I use this information later to make sure that I am not continually making infinite and infinite states. And here is a simple ifs check to see if I have the complete array, that I stop iterating and I change this final array to the current array, and then I print it out and put out the stats, like how long it took, like how many iterations we did, and how long it took. So I'm gonna start it again, um, and then I'll go into this get next moves section. Um, Here, you give it a move that has been taken. So what it does is that it brings it up to this get next move method, and essentially we create a queue that we are going to add on to the end of our main queue, um, and we locate the empty space. After that, we go into these large if statements where basically, if depending on where the blank space is, like here, if it's x is if it's y is 0, then no, if it's x is 0, then we process it a certain way versus processing it another way. And sorry, that was not that descriptive. Essentially, we figure out, hey, where is this located? And then we double check to make sure that, hey, we're not going to go back on the previous move that we just did. And if everything is all right, then the queue adds in the move and sets the current move to what the previous move is. So essentially, this is just a bunch of if statements that do that, and then here uh, I have essentially what this does is that we sorry we get the board that the current state is, and we get the spot that it's supposed to move to. And because the board is still the same as the initial current board, because although we make a deep copy here, so this is basically updating the board for each state in the queue. And we get the board, we get the move that is to be made, and then here we do this swap of the element where we get the number of the element that's supposed to be there and swap the other one with none, and then we return it and add it to the queue at the end here. This get number is just like a method that I made for because I was having issues with copying numbers. But yes, as you can see, this one only ran for 6 seconds, and it solved it again. If you would like to check out my code, please do. Thank you very much. Have a nice day.